In 1803, the body of an executed prisoner in London suddenly opened its eyes before a crowd of onlookers. This was no horror story, it was an anatomy demonstration at the Royal College of Surgeons. Scientist Giovanni Aldini had just attached electrodes to the corpse of the prisoner, George Foster. When electricity coursed through the body, the dead man's jaw trembled, his facial muscles contorted, and one eye snapped open. When the electrodes touched his torso, he even raised his arm, as if struggling to wake from the abyss of death. Aldini was no charlatan. As the nephew of anatomist Luigi Galvani, he inherited not only his uncle's legacy, but also a groundbreaking ambition to use electricity to break the chains of death. More than a decade earlier, his uncle had made a chance discovery on the dissection table: electricity could make the legs of a dead frog twitch violently. This led Galvani to propose the animal electricity hypothesis, which argued that life itself was a form of inherent electrical energy. Now, the nephew sought to conduct the ultimate experiment on a human corpse. Though the demonstration failed to bring the prisoner back to life, it did tear away the age-old veil shrouding the mystery of death. Aldini declared to the world that death might not be the final judgment, where the soul fades away, but a physical process that could be observed, intervened in, and even temporarily reversed. Yet this discovery unleashed one of the 19th century's deepest nightmares. If the dead could be jolted into movement, might doctors mistakenly declare someone dead? The fear of being buried alive spread like a plague. Craftsmen scrambled to invent a bizarre solution: the safety coffin. They fitted coffins with their tubes, ladders, and a rope that connected the corpse's wrist to a bill above ground. The logic was simple: if you woke up underground, a gentle pull would send a final plea for help to the world above. This seemingly absurd invention captured the era's existential dilemma. The line between life and death was far more blurred than anyone had imagined. The 20th century's medical revolution would blur this line even further. In 1960, modern cardiopulmonary resuscitation (CPR) was formally established through chest compressions. People whose hearts had stopped could be pulled back from the threshold of death. Soon after, external defibrillators turned echoes of death into a common scene in hospitals. Death was no longer an unchangeable verdict. It became a medical emergency that could be intervened in and delayed. But new problems emerged. The invention of the ventilator created an unprecedented form of life. Patients whose brain function had completely ceased, yet whose hearts continued to beat thanks to machines. Were they still alive? In 1967, the world's first heart transplant pushed this question to the edge of ethical crisis. To transplant a healthy heart, the donor's heart first had to stop beating. The medical community was forced to answer: what is death? 4 years later, Harvard Medical School offered a groundbreaking definition: brain death, when brain function is irreversibly and permanently lost. A person is legally dead, even if their heart and lungs are still working. For the first time, the judgment of death shifted from the warm heart to the silent brain. But the real battle lay in the deeper, microscopic realm. In the early 20th century, Nobel laureate Alexis Carrel claimed to have kept a piece of chicken embryo heart tissue alive in a lab for over 30 years, far longer than its natural lifespan. This immortal heart fueled the belief that cells were inherently immortal, and aging was merely a result of poor environmental conditions. But the myth was eventually debunked. In 1961, microbiologist Leonard Hayflick discovered that normal human cells stop dividing after approximately 50 divisions. The Hayflick limit revealed a harsh truth: life is programmed with a countdown from the very start. So what is this countdown device? The answer lies at the ends of our chromosomes. Scientists found that each chromosome has a protective sequence called a telomere at its tips. Every time a cell divides, its telomeres wear down and shorten like the plastic caps on the ends of shoelaces. When telomeres become too short to protect a chromosome, the cell stops dividing and begins to decay. Most cancer cells activate a substance. Nature, however, has exceptions. Cancer cells seem to have broken free from this constraint. A substance called telomerase, which constantly repairs worn telomeres, granting them the ability to live forever. In 1951, an African-American woman named Henrietta Lacks died of cervical cancer. Without her knowledge, doctors took a sample of her cancer cells for research. Surprisingly, these cells showed unprecedented vitality in the lab. They could divide infinitely and never age. These became the first immortal human cell line, known as HeLa cells. Over 70 years, they have been shipped to laboratories worldwide, contributing to the development of the polio vaccine, the mapping of the human genome, and even COVID-19 research. Though Lax herself died, her cells achieved immortality in another form. Even more astonishingly, death is not always a bad thing for life. In 1972, scientists discovered a programmed, active suicide ritual in cells, which they poetically named apoptosis from the Greek word for falling off, like leaves from a tree. This is no accident, it is part of life's design. During embryonic development, the ordered apoptosis of cells between fingers shapes our flexible digits. A tadpole's tail disappears through massive apoptosis, allowing it to transform into a frog. Later, scientists identified the genetic switches that control this self-destruction process in tiny organisms called nematodes, and these genes are surprisingly similar to their counterparts in humans. As scientists gained the ability to tweak the biological clock of cells like watchmakers adjusting a timepiece, an ancient idea resurfaced. Can we artificially slow aging, or even defeat death? In 1993, Cynthia Kenyon extended the lifespan of nematodes by 100% by altering just one of their genes. This discovery ignited the modern field of anti-aging research. From calorie restriction to targeted drugs, scientists have found that aging is not an unbreakable law, it is a biological program that can be intervened in. This wave has even attracted tech giants from Silicon Valley, who have invested billions in startups, hoping to hack death using the same logic they use to hack software. More radical gamblers have set their sights on the future. In 1967, psychology professor James Bedford died of cancer and became the first person in the world to be cryogenically preserved. His body was injected with antifreeze and lowered into a tank of liquid nitrogen at 196°C, waiting for a distant day when technology might bring him back to life. This is the ultimate bet that the pace of human technological progress will outrun the slow decay of his body in the cold. Others have dreamed even further. Since the physical body will eventually decay, why not scan and upload consciousness and memories to the cloud, achieving digital immortality? As technology advances, humanity's tools to fight death evolve by the day. But we seem to have overlooked a more fundamental question. Why did we fight death in the first place? We often say that death is the engine of evolution, making space and resources for new generations. But looking back at history, every great leap for humanity has been a bold challenge to the laws of nature, from mastering fire and farming, to decoding the genome, to exploring space. We are who we are precisely because we refuse to accept nature's limits. Our quest to extend the length of life may not stem from fear of nothingness, but from a desire for infinite possibility. When our ancestors first looked up at the stars, their curiosity to transcend their own existence was no different from our modern desire to edit aging or upload consciousness. Defeating death may not be the end of our story, but the true beginning of humanity's journey as a species breaking free from our biological cradle and embarking on the next chapter of civilization. Yet in every era, each individual faces not the question of why to live, but how to live. We are not merely moving toward death, we carry death within us. And it is death that gives life its boundaries. Within those boundaries, we create stories and experiences that transcend both life and death.